Hello everyone, we are group number 20. My name is Kajeevan. My partner is Syed, and we're going to be presenting you two open source softwares and the vulnerabilities that was identified by the open source community and how it was remediated by the developers. The first one we have picked, Yoast. It's a search engine optimization tool. It's the number one WordPress SEO plugin, and Yoast SEO makes sure your site meets the highest technical SEO standard. It gives you the tools to optimize your content for the search engine and overall readability. More than 12 million website users Yoast, and I want to briefly introduce what WordPress is. WordPress is an open source content management system. It's licensed under the open source GPL version 2, and this content management system can be paired with MySQL or MariaDB database, and it can provide one of the powerful website that can be created within minutes. And there are hundreds, if not thousands, of free templates available to customize the look and feel of your website. About 43.3% of all website on the internet uses WordPress, and about 2 million downloads every year, and WordPress is growing very fast. And the reason we picked Yoast and vulnerability is I have used WordPress and Yoast in the past, and very much interest to make sure these open source platform remains secure. That we are going to look at is CVE 2019-13478. It's a cross-site scripting vulnerability that affects Yoast SEO plugins, and what it does is improper neutralization of input, and basically it will lead to a cross-site scripting, and where this can lead to disclosure of information stored in user cookies, possible redirection of victim's computer to malicious page, as well as account compromise and bypass user role-based access control. Basically, it means like if I was a user of a website, I could escalate my privilege to an admin to that website. Affected versions are of Yoast SEO plugin is anything that was built before 11.6.rc5 for WordPress. So RC5, they have released a patch for this vulnerability. And impact of this CVS V2 overall score is 9.9, given it impacts confidentiality, integrity, and availability, all three triad of CIA. And it will completely impact the confidentiality, integrity, and availability, where an attacker can totally change the websites and the integrity of the website, and also they can disclose or reveal private information that's stored on the website, and also they can completely render the website unavailable by modifying certain configs or taking the website completely offline and serving them with a different page. And access complexity is fairly low, given there is no special access required. Most websites uses this. It's a public facing website, if not all of them, given it's meant for search engine optimization, and it doesn't require any special authentication to exploit this vulnerability. And the code change, the developers had made this, added this code change to previously you were able to, they were verifying only certain fields. Now all the content of that input would be validated, and so therefore the cross-site scripting would no longer exist by filtering the input. Preventing these type of attacks in the future, and especially like if you are developing your own application, or even if you're using third-party codes, we should be cautious on like what they would do, and filter input upon arrival. So ensure like all input that's user can change, it's validated, and only if the filtered input is inputted into the database or further processed for execution. And any validation that's performed on the client side should be again validated on the server side. There are tools that we can use, including Burp Suite, for example, can bypass a lot of these validation. Encode data on output. At the point where user controllable data is output in HTTP responses, encode the output to prevent it from being interpreted as an active content. Use appropriate response header. This is to prevent cross-site scripting in HTTP responses that aren't intended to contain any HTML or JavaScript. Finally, you can use content security policy, and this is the last measure that you can put in. You can basically enabling content security policy to reduce the severity of any of these cross-site scripting vulnerabilities. And how do we detect these vulnerabilities? There are so many automated tools, including NetSparker and Qualys. They are commercially available tools, and there are various open source tools as well. And Burp Suite is a tool that I've used in the past to manually analyze the code or perform SQL injections or cross-site scripting and fuzzing attacks. And also using the black box method cross-site cheat sheet published, and take that and you can try various different attacks against your web application to make sure it is not vulnerable to cross-site scripting. Fuzzing can help us detect any input validation error. This would be useful. Once we identify any input validation error, we can try to manipulate to see if there's a cross-site scripting vulnerability exists within that as well. Thank you.
Hello everyone. The vulnerability I will be talking about today is CVE 2021-32708. This is a code execution vulnerability that takes advantage of whitespace normalization. Whitespace normalization is the removal of white spaces within a code or path name. In the case of our application, the path or file name is not checked against an allow-only list, rather only checked against a deny list, which could be exploited. If the supplied path name or file name contains any white spaces, then the file stored in the directory could be accessed and allow a malicious user to execute the PHP code. The way the attack would work is that the attacker would provide a path name with some unsupported characters. The unsupported characters would be replaced with white spaces. If the attacker would smartly phrase a path, then he or she could execute the code from within the library, as the characters would get removed. This vulnerability is addressed with some code changes, which we will be having a look at in the later part of the presentation. To understand the impact of this vulnerability, we can just take a look at its CVSS score. It gains a base score of 9.3, impact score of 10, and exploitability score of 8.6 on the CVSS version 2 vector. Overall, it scores a rating of 9.3, and this is reflected by how it can compromise confidentiality, integrity, and availability with little effort. In addition with that, it requires no authentication and only medium access complexity, that is, with some pre-existing conditions to be met. Next, we take a look at the open source application affected by this vulnerability. The name of the application is FlySystem. FlySystem is an open source file storage library for PHP. It helps to provide a single interface for many types of file systems. It provides a consistent experience for all types of storage and prevents being locked down to a single vendor. The security issue for the application was addressed in an update. Version 1 users were required to upgrade to the version 1.1.4, and version 2 users were required to upgrade to 2.1.1 for the fix. Moving on, we finally look at the code changes made by the developer to address the vulnerability. Firstly, the developer created an exception that would be raised when an unrecognized file path is detected. If a user tries to enter a path name with unsupported characters, this exception would be thrown with an error saying corrupted path detected. In this next slide, we see in red how the code was previously written. We can see that it would remove some of the special characters with white spaces. However, that proved to be insecure. So they replaced it with a code that rejects white spaces altogether. And in the code below, we can also see how previously some characters used to be replaced with blank spaces. But in the new code, if it tries to do that, or if it detects an unsupported character within the path name, it will throw the exception instead. To sum up, an exception was created that would be raised when the criteria is met. The code was changed to make sure to reject the input rather than remove the characters and replace them with white spaces. We also saw how the code was changed to throw an exception compared to its previous iteration. Ultimately, what we see is that next time a user will not be able to trick the system into taking a smartly phrased path name to bypass the system. To conclude, we observed two security vulnerabilities that could very easily and readily access and penetrate the systems. We also witnessed the patches made to two of the applications that were victims to the identified vulnerability. From all of this, what we understand is that software security is super important in today's world, where vulnerabilities can be easily exploited. As we have learned in this course, that designing or developing software with security in mind will be the best approach when it comes to security. But having additional security testing, audits, and penetration testing should also be conducted to combat any new or unexpected vulnerabilities. That brings us to the end of the presentation. This is our references, and we'd like to thank you for tuning in, and we hope you enjoyed our presentation. If you have any questions, we will be answering them.